Okay, so today's lesson here, we're going to look at graphing what are called piecewise functions. Now, piecewise is something that's going to be brand new to most of you, and what it refers to is a situation like you see in the graph here, where you see our graph starts on this purple line and jumps at -1. When x equals -1, our line jumps up to our red line. And so what you notice is our rule changes. What we're doing changes at that point. And so that's what we are talking about when we're talking about a piecewise function, is a situation where we're following one rule, then that rule changes in the middle of the problem. This has a lot of real life examples where situations such as oftentimes cell phone plans, for example, you might be paying a flat rate for your first 400 minutes of talking, but after 400 minutes, what happens is your plan changes. Then all of a sudden they start charging you at a different rate. So therefore, your graph is a linear situation where it follows the same pattern until you hit a certain number of minutes. Then it jumps to another line. So that would be a real life example of what we're doing. Alright, so now we have some idea of what we're doing here with a piecewise function. We have some idea of what we're talking about. As we jump ahead here and look at our first example, we have an equation of a piecewise function given to us here. And you see, we talked about a piecewise function being in two parts, where you're going to follow one rule for a certain amount of time, and then you're going to jump to another rule. So here, our example f of x equals 2x minus 1 when x is less than 2. That refers to, that's our first rule. That's where our plan is going to start from negative infinity until x equals until x equals positive 2. We're going to follow the pattern f of x equals 2x minus 1. Once we get to that point, that value when x is 2, our rule or our plan is going to change. We're going to have a jump in our graph, and we're going to see a change at 2. After you pass 2 on the x-axis, our graph is going to follow the rule y equals -1/2 x plus 2. So let's look at what this looks like on a graph. Our first equation here is y equals 2x minus 1 when x is less than 2. In order to create a piecewise graph, we need a couple of pieces of information. We need the slope of our line, and we need to know the critical point. That critical point refers to the point where your graph is going to change rules, where your graph is going to stop being on the plan y equals 2x minus 1 and change to the plan y equals -1/2 x plus 2. And that occurs when x is 2. So to find our point on the line, y equals 2x minus 1, when x is 2, we plug 2 in for x, which gives us 2 times 2 minus 1, which is 3. So we know our slope of our initial line is 2, and our critical point, or the end point for that graph, is at 2, 3. So we go to our graph, we go to 2, 3, and we're going to put an open circle. And the reason why the circle is open is just like what we did when we did our inequalities, where it's less than, it's not equal to, so that means it is an open circle. Now normally from here, if you were graphing a linear equation, you would start at a point and you would apply your slope. You would go up 2 over 1 and you would draw in your line. The problem with that is this is a piecewise function. Our graph doesn't go to the right because we're only graphing that rule, y equals 2x minus 1, when x is less than 2. Or in other words, we have to go to the left. So we need a line that has that slope of 2, but instead of going up 2 over 1, we have to go to the left. So we have to go down 2, left 1, with the idea being that if you make 2 negative movements, down and left, that's going to give you a positive slope, because a negative over a negative is a positive. So we draw in our line to the left, following our slope of -2. And we're going to erase that line to the right, because that rule no longer applies. When we get to that point, 2, 3, our rule no longer applies, so we can't graph anything to the right of that point. We can only graph to the left, because that's where less than would be. So now, we graph our second line. And you'll notice here, we're working with two different functions, two different equations. So we're going to treat them as completely separate problems. We're not going to try to graph this whole equation, the whole formula at one time. We're graphing this two separate problems. So you can see our second equation over on the right is y equals negative 1/2 x plus 2 for when x is greater than or equal to 2. So our slope is negative 1/2 and our critical point is 2, 1. So I pull out my critical point of 2, 1 and I'm going to graph that with a closed circle because that's for x is greater than or equal to 2. So therefore that is a closed circle. And my slope of my line is negative 1/2. So I would go down 1, right 2. And now, because we're going to the right, because we're graphing the line where x is greater than or equal to 2, we are going to just do a standard slope. Down 1, right 2, and we draw in our line. So this would be a graph of our piecewise function that we started with at the top of the page here. The graph of that piecewise function looks like this. It follows the green line until we get to 2. When we get to 2, the rule or the plan changes, and we jump to the blue line, and we follow that line for the rest of the graph. So let's look at one more example. And we're going to go through this a little bit more quickly in the way you would probably do this on your own paper. If we were going to graph this function, this piecewise function, we always start by finding our critical point. Our critical point for our first equation is going to occur when x is negative 1, because that rule is only going to apply until we get to negative 1. So if I plug negative 1 into my equation, negative 3 times negative 1 would be 3. 3 minus 4 is negative 1. So that graph is going to start, is going to have an end point at negative 1, negative 1. So I go to negative 1, and I put an open circle on my graph. And now, when I go to graph that one, my slope is negative 3. So normally I would go down 3 over 1 and put my dot. And you can see the dot there on the graph. However, this graph doesn't go to the right, because this graph only is graphed when x is less than negative 1. So I have to go to the left. So I have to do the exact opposite slope. If I went down 3, right 1, I'm going to go up 3, left 1 to put my next point that's on my line. Then I connect the dots to draw in my line. So that is the first equation there. F of x equals negative 3x minus 4 for x is less than negative 1. Now, we're going to jump and act like we're on a completely separate problem. My critical point is going to be at negative 1, comma. I have to plug negative 1 into my second equation. 2 times negative 1 is negative 2, plus 1 is negative 1. So you notice our critical points are the same. Our critical points are both at negative 1, negative 1. So when I go to graph my purple line here, I'm going to color in that dot because that now became a defined point. That is an equal to, so I can graph that dot. Now, to graph my next point, to finish my purple line, I look at my equation, my slope is 2. So therefore, I go up 2 over 1, and my graph is going to the right, because we're graphing where x is greater or equal to negative 1. So hopefully you do a better job of drawing your lines and actually go through your dots. But these are piecewise functions. This is what we're talking about. Whenever you hear that term piecewise functions, it means your graph is going to change rules somewhere in the middle of the problem. This is something that people tend to have trouble with, so please come in with any questions you have tomorrow or on Monday. We'll see you Monday. Have a nice weekend.